It's really, oh, it's happening. All right, good. So I'm going to talk to you a little bit about that. So what do we do within COSIMA? We develop global ocean CIs model configurations. Perhaps you've heard of the Access Ocean Model or the Access Climate Model. We are developing essentially the ocean component of the Access Climate Model. Other thing we do is we run these ocean models with various forcings, either repeat year or interannual forcing from reanalysis. So we also apply for supercomputer time, and we get a lot of that from on the Australian supercomputer, and then we run a lot of models and we save a lot of data. We also run perturbations, like we change freshwater fluxes, winds, bathymetry, anything you can imagine, and we also run that to ask science questions. And most importantly, we analyze all these things, we do science, and we figure stuff out. And to put things in a more perspective, from like more to scale, is mostly what we do, and most of these people that you see in the photo do is that they analyze model output, and they think of new experiments. They, and they and then run them and then analyze to understand ocean dynamics or climate dynamics. So there's a lot of that happening. And through the years, we've developed a way to share how we do this analysis. So then people don't have to reproduce everything from scratch every time. And that's what I'm mainly going to talk about. So what are two tools we have developed in COSIMA? First is what we have a Python package, we call it a COSIMA Cookbook. And it's essentially a database, a way to store information about where all our model output is in the supercomputer. And also information about each model run, metadata. We don't use the cloud, and this is like, I'm a bit ashamed to talk into Pangeo community and saying we're not using the cloud yet. I think this is one of the things we're pushing forward, but there's like a lot of bureaucracy in doing that. We try to be, compliant with Australian NSF rules, and yeah, I don't really know how to move forward with that, but there is plans to do that. But until then, because we don't want to be sharing directories on the supercomputer, we have this COSIMA Cookbook, which creates a database, and then people can go and search, oh, I want a model which is this resolution and has this diagnostic, and they can get it immediately without thinking of where in this directory, where is the netcdf file, oh my God. And the other thing we have is what we call COSIMA Recipes, which is a collection of notebooks that demonstrate various analysis or various things various physical analysis you can do with all these model outputs. And this has evolved in time, and it has become a really useful library of examples that nowadays every student, every new researcher that joins the community, they use that as their starting point, and they can really get started really quickly by taking one of these examples and taking it away. And that's what I'm gonna mostly talk about a little bit and show you a little bit how this has evolved. So COSIMA Recipes, it started as a collection, as a directory in a repository with a bunch of Python scripts that sort of worked. They worked when they were uploaded, and then slowly they became outdated. Some model output was moved somewhere else. Some diagnostic was not there anymore. So it was it was a bit of a mess. At some point, then we said, okay, we'll convert all these scripts into Jupyter notebooks with some more description, have some plots there. You know, this is like, that's the modern way of doing things. And that was a good way and good thing. And we moved all this into a new separate repository. We call it COSIMA recipes. Then COVID came and we were all stuck at home. And somebody had this brilliant idea, oh, let's do a hackathon. It was still early COVID times. Everybody was at home and it was still cute to work from home. So we said, okay, we'll do a one day, we will all gather in Zoom and fix these notebooks and add more. So we added tutorials, we made all the notebooks work, we added more notebooks, and we created a website that was generated from these notebooks. It was a very productive day, and I mean, essentially we all kept working on it for a week or so. Yeah, that really bumped up this repository to a new level. And then things started becoming outdated again. And this year, in the beginning of this year, we had another hackathon where we added more examples of how we analyze model output. We added examples for MOM6. Now we are using models that use MOM6 as their ocean core. We added more tutorials. We added what was really important, a continuous integration. So every Sunday now, all notebooks are being submitted automatically on the supercomputer, and they're run, making sure they can run to the last cell. And if not, somebody's getting an email notification about that. So we go and fix everything as soon as it breaks. That's what's important. And we also had a lot of fun. It was like, we were like 50 people in this hackathon. There was a dress up theme. I was dressed up like Ariel from The Little Mermaid. It was really nice. So that's building into what it's really has become a community, and people who join us, they get hooked and they want to stay. It's a little bit like that. So what came out of this hackathon is that we created a tutorial that was even picked up by CFXRA, and I was really amazed seeing that. So now not only are the COSIMA recipes tutorials are like showcased elsewhere. So we have proceeded to what I called a global outreach. So that's about it. I'm gonna showcase a little bit of the repository and this website now. And so let me go through that. So this is the repository. This is, even the logo is a product of somebody's free time and spending afternoons. I really like the logo. So this is the repository. We have, folders with notebooks of how to create your own database, how to make maps or whatnot. And all these, all these notebooks are updated and or submitted via pull requests, and they are being reviewed. And the review is an actual review, and there's like a back and forth process until we are all happy with something that is generic enough and interesting and has enough explanation to be useful for many people. And from these notebooks, this website is created automatically. So for example, here you can see a bunch of tutorials. There's a tutorial of how do you make maps, which let's click it. You can start and see, how you load some output from one particular experiment that we have, and how we can start with a map which is just .plot and take it to a next level to something that that is like looks like that. So this sort of tutorials are really useful for students or researchers that coming in. They go through these things, and after a week or so, they are like up to date with everybody. We have found this sort of a centralized location for having all these examples and tutorials really useful. And what other things that we have a lot of examples of either simple or elaborate model analysis that one can do. Here there's like an example, how do you compute geostrophic velocities from sea surface height? How do you compute the barotropic stream function? There's all sorts of things here, and how do we add some Lagrangian particles to our model output and affect them? I don't want to, like, perhaps we should stop here. And but yeah, that's what I wanted to showcase to you. Well, I think that's it. Feel free to start the repository if you like it. Just saying.
All right.
Yeah.
Thanks, Navid. That was a really great overview of COSIMA. Okay, I will open the floor to questions. And maybe while we're waiting for some questions, I'm wondering a bit about the COSIMA Cookbook, which you said is a Python tool. Is that a Python tool specifically for kind of working with Australian climate models?
No,
Okay.
no, not necessarily. It's essentially what that tool creates. It creates a database for where a bunch of netcdf files are. So I don't think it's only Australian. Anybody can install it via pip, and and then if you have like 3-4 model runs in various directories with various variables and diagnostics, you can just say, create a database. This is my directories, and then it will create a whole database with all these model variables, the name of the diagnostics, the metadata of that it will read through from the netcdf metadata, and then you'll have a database and say, okay, where is my whatever 3-dimensional daily temperature fields, and then you can load them without having to know I have to go in this directory and that subfolder and whatnot.
Okay, so it really helps with the findability of available data sets.